Hello Gators, this is 6-3 Properties of Parallelograms. I can use the properties of parallel lines, diagonals, and triangles to investigate parallelograms. Let's take a look at a parallelogram. It is a quad with both pairs of opposite sides that are parallel. Parallel sides will allow us to know something about angles. And so if I'm looking at these green parallel lines, and I use this as my transversal, I'm going to be able to say that this angle is congruent to this angle. If two lines are parallel, alternate interior angles are congruent. If I use the red parallel lines, and again, this is the transversal, these angles will be congruent. These are alternate interior angles. Again, if two lines are parallel, alternate interior angles are congruent. If I use this as a reflexive side, then this triangle and this triangle will be congruent by angle, side, angle. The side is an included side, and here are the angles. When that takes place, that means rigid motion will take place, and I will be able to find other parts that are congruent. And that's what we're going to do right now. Let's take a look at, again, drawing a diagonal. This will be our transversal for this line and this line. And so this angle will be congruent to this angle. And when I use my other parallel lines, this side and this side, then I'll know that these two angles are congruent. So I can say triangle XWZ is congruent to triangle. Now remember, the X goes with the Z, and the W goes with the Y, and then we have X again, by angle, side, angle. Now once those triangles are congruent, we can say X W, that's this one right here, XW will be congruent to ZY. And though that means we can say this is congruent to this. And we can also say WZ is congruent to YX. And these are all by corresponding parts of congruent triangles are congruent. We'll be able to say that this is congruent to this. So when you have a parallelogram, opposite sides are congruent. Let's go ahead and use this. This is a parallelogram, so if this is 3.27, this will be 3.27. If this is 5.09, this will be 5.09. Now we can use this idea to do problems that will require a little bit more work. We know that this side is congruent to this side. So we know that 4x will be equal to 5x minus 3. If I subtract 4x on both sides, that'll be 0 is equal to x minus 3. Add 3 to both sides, x is equal to 3. Now what if I had picked the other two sides instead of equal to each other? Let's see what I would have gotten. So I'm going to subtract 2x on both sides. That's 5x minus 3 is equal to 12. Add 3 to both sides. That's going to be 15. And then x is equal to 3. So I got x equal to 3 regardless of whether I put these two equal or these two. So the value of x is 3. Now let's find the length of each side. This side will be at 12. This side has to be 12. This side is 2 times 3, which is 6. 6 plus 12 is 18. And this side will be 18. Let's take a look at a parallelogram and notice that it's part of a bigger picture with parallel lines and a transversal. We're not using the diagonal as a transversal, we're going to use one of the sides as a transversal. When this happens, angle 1 and angle 2 are what we call same side interior angles. And we know that same side interior angles are supplementary. That means they add up to 180. Now let's go ahead and talk about these two. These two are going to be same side interior angles for these parallel lines. So these two will be supplementary as well. These two will be supplementary. So we have angle 1 supplementary to angle 2, and we have angle 2 supplementary to angle 3. And when that happens, when they're supplementary to the same angle, we had a theorem that says then the other angles must be congruent. So in other words, this angle will have to be congruent to that angle. All right, so let's go ahead and try this problem. Remember that we are working with parallel lines, and so these consecutive angles here have to be supplementary. So 180 take away 114, that's 6, 7, and that's a 6, so this is 66 degrees. And remember, opposite angles are the same, so that's 114, and then this is 66, and this will be 66 to get as well. Let's now look at, we just were working with this theorem, consecutive angles are supplementary. So this angle and this angle have to add up to 180 degrees. So that's what we were doing. Now let's talk about what we discovered about the opposite angles. Remember that we know these two are supplementary, but we now know that angle B and angle D are congruent. Opposite angles are congruent. And if you don't remember this, then you can always think about it this way. Let me get rid of that thing. You can always think about the fact that these two lines, this triangle and this triangle are going to be congruent by side, side, side. And when these two triangles are congruent, angle B has to be congruent to angle D by corresponding parts of congruent triangles. And if we want to get angle C congruent to angle A, then we know these triangles are congruent by side, 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 and therefore these two angles will be congruent by corresponding parts of congruent triangles are congruent. All right, so let's go ahead and find the measures of these angles. These happen to be consecutive angles, and consecutive angles are supplementary. So I'm going to take them and I'm going to add them up, and I'm going to equal to 180. So this goes to 0. This is 9A equals 180. So A is equal to 20. So this angle will be 20 and a 5, so that's 25. And this angle has to be 155. And opposite angles, 155. And then this one is 25. And that's how we do it. And here's the summary of the properties of parallelograms so far. So far we understand that consecutive angles are supplementary, opposite angles are congruent. And we also know that opposite sides are congruent and opposite sides are parallel.